So I hope you're having fun with this crazy long division, and maybe you're missing the days of grade 4 when there wasn't any x's involved in long division, but now there are. However, I do have a shortcut for you, and it's called synthetic division. So if you would like a shortcut, feel free to use this. However, note that long division is always going to work and will never fail you. But if your hand is hurting because of the lines of polynomial equations that you have had to write and you are looking for something to help you, fear not, synthetic division is here. So it's sort of memorizing, I will warn you. I'm not going to go into why it works. I'm just going to show you how it works. So note that you can only use this when our divisor is linear. So if we have an x squared situation where we're dividing a quadratic divisor into a dividend, then we can't use synthetic division. So let's start with when the leading coefficient of the divisor is 1. So here is our divisor, x minus 3. It's linear, check, so we can use this shortcut called synthetic division. And its leading coefficient is 1. If its leading coefficient is not 1, you can still use synthetic division, but we got to do an extra step. Alright, so here is your step-by-step guide to use the shortcut of synthetic division. I hope you enjoy. So first we're going to start off by making this little contraption of a big long L. Okay, and here we go. On the top of this L, so right over here, I'm going to write the coefficients of the dividend. So the coefficients of the dividend go up here. If we're missing any terms, like the x squared term or like degree 0 term, then we've got to add in a coefficient of 0. But we're not here, so we're going to add in the numbers 3, -5, -7, and -1. Okay, so second step. The number that we're going to write here is the 0 of our divisor, which means if I were to set this thing equal to 0, what would x be? And in this case, x would be 3. So that's the number that we're going to write out here. Okay, so next on our trip to the land of synthetic division, we're going to bring down this first number. Don't ask me why, but that's just going to happen. Okay, so our next step, so actually write this in black. Okay, so our next step is we're always going to multiply by this number out here by all of the numbers that we end up having down here to get to our next number. So here's what I mean by this. So I'm going to multiply 3 by 3 first, and that answer is going to come up here. So 3 times 3 we know is 9. Now in this section here we're going to be adding. So next we're going to do -5 plus 9, and that's going to give us -4. Then our next step is we're going to take this 3 and times it by -4 and bring it up here. So we have 3 times -4, that's going to make -12, and again we're going to add. So -7 plus -12 is going to give us 5, and we're going to keep on rolling. So we've got 3 times 5, and that's going to give us 15. So we're going to put the answer up here. And we're ready to add them together. So -1 plus 5 is 14. And believe it or not, we're actually done. So these are going to be the coefficients of our quotient. So how to figure it out is work backwards from this last number here. The last number is always going to be our remainder. So this is our remainder R. The next one is going to be our constant value. So that is our constant. The one beside that, that's going to be our degree 1 term. And the one beside that is going to be our degree 2 term, and so on and so on. So therefore, when we take those two things and we divide each other, we're going to be left with the function f at x is equal to 3x squared minus 4x plus 5 with a remainder of 14. So we could do long division to check this. but actually I tricked you and we already did this. If you check way back on our first page, the first slide of this video, we actually did this exact same question when we were learning how to use long division. And guess what? We got the exact same answer, but we got it much quicker. So if you prefer using synthetic division or an opportunity arises where you can use it, go for it. But remember, the divisor has to be linear, and in this way of using synthetic division, you need to make sure that the leading coefficient is 1. Example 7 is just the same as something we've already done. We've already proved this using long division. So it says, is x plus 2 a factor of this guy here? But because we know what the answer is, and the answer is yes, we should have a remainder of 0, let's triple check it using synthetic division. So can we use synthetic division properly? So if you feel like you can do it, set it up on your own, try it on your own, and then just skim through the video, make sure that you get the correct answer. Or you'll know if you have the correct answer if you get a remainder of 0. If you need some help setting this up, do it along with me. Okay, so remember, inside our L goes our coefficients of our dividend. And we got to rearrange this guy just like we did before. So we're going to go x4 first, and then minus 2x to the power of 3. There's no x squared term, so we're going to put plus 0x squared, and then plus 13x, and then minus 6. So let's go ahead and put those coefficients in there. So we've got 1, negative 2, 0, 13, and negative 6. And then we have the 0 of our divisor is negative 2, so that's the number that's going to go there. Okay, so let's drop the 1, and then we're going to multiply negative 2 times 1. That's going to make negative 2. When we add those together, we're going to get negative 4. Then we've got negative 2 times negative 4. That's going to make positive 8. So we're going to add 0 plus 8, which is 8. And then we have negative 2 times 8 is going to be negative 16. Add those together, and we'll get negative 3. And then finally, negative 2 times negative 3, that's positive 6. And when we add those together, we get 0. So there's our remainder. So here is our remainder. Working backwards, this must be our constant. Here is our x term. Here is our x squared, and here is our x to the power of 3, which means that when we divide those two, we get the solution f of x equals 1x to the power of 3 minus 4x squared plus 8x minus 3 with a remainder of 0, which is the exact answer we got in example number 4. And because it's a remainder of 0, we know that it is a factor. All right, you're probably exhausted by now, but there's one more trick. If you like using synthetic division and it's not too memorizing for you, you like the shortcut, well, what happens if our divisor is linear but our leading coefficient is not 1? Well, we can still use synthetic division. It's just going to be a little bit different. So first, we're going to start it off in the same way. So we're going to start it off making this L. And inside the L goes our coefficients. So taking a look here, we've got 6x to the power of 4 plus 3x to the power of 3. We're missing the squared term again, so we're going to put plus 0x squared. We have minus 11x plus 25. So putting those coefficients in there, we have 6, we have 3, we've got 0, we've got negative 11, and we've got positive 15. All right, so now for our 0 part. Okay, so normally we would put the 0 of 2x minus 3, which would work out to 3 over 2. Except with a fraction here, this is going to be very, very difficult. So instead what we do is we ignore the 2. And we say, what would this 0 be if the 2 wasn't there? Well, that would be a 3. So we're going to put a 3 here. Now the 2 is going to come into play. And it's going to come into play a little bit later. So first we're going to start it off in the same way, which is we're going to drop the 6. And here's where that 2 comes into play. Because we have a 2 unaccounted for here, we're going to divide all of our answers that we get by 2 because of that 2 here. So if this was a 4, for example, we divide all of our answers by 4. If it's a 5, we divide all our answers by 5. So because it's a 2, we're going to divide our 6 by 2. And that is the number that we're going to carry into our next step here. So 6 divided by 2 is 3. So this is the number that we're going to multiply by 3, and then we're going to bring it up here. So 3 times 3 is 9, and again we're going to add. So 9 plus 3 is 12, and then we have to divide by 2 again, and we're going to get 6, and then we continue again. Now we're going to do 3 times 6, bring that answer up here, and we have 18. Add it together, we have 18, divide it by 2, and we have 9. And we're going to continue the fun by multiplying 3 by 9, and we know that that makes 27. Okay, add those together. We are almost there. Imagine doing this by hand. Long division. We'd be here for an hour. So we have 16. Then we're going to divide this guy by 2, and we know we have 8. And we've got one more to do. Next, we got 3 times 8. 3 times 8 is going to give us 24. We're going to add those together. I'm not sure why I put a little plus sign here, but it won't erase. Okay, so we're moving on. Okay, so I had a 15 there. Mistaken. It's a 25. So our last step is to take 25 plus 24, which is going to give us 49. Ta-da! All right, so weird rules of synthetic division, you leave that 49 the way it is. So that is our remainder. We're going to drop it down. So yes, it's very memorize-y, but if it saves you some time and you like it, awesome. So here is our remainder. Here is our constant term. Here is our x. Here is our x squared, and here is our x to the power of 3, which means that when we divide this ugly thing by this 2x minus 3, we are going to get the function f at x equals 3x to the power of 3 plus 6x squared plus 9x plus 8 with a remainder of 49. Done. And if you don't believe me, spend half an hour of your life and do the long division.